Hi, this is Mrs. Basin, and today we're going to talk about chemical reactions and equations. So we're going to start by looking at what is a chemical reaction and how do we know if a chemical reaction has taken place. So when matter undergoes a chemical change, a chemical reaction takes place. So that means new substances are formed as the result of a chemical reaction. When you have a chemical reaction, sometimes you are able to actually see indicators that you can observe that let you know that a chemical reaction has taken place. So the first one is a color change, and you have to be careful with a color change because sometimes things change color as a result of like a mixing of food coloring, but sometimes the color change is the result of an actual reaction. So we'll do lots of examples and talk more about that one in class. You could have a gas being formed. If the gas is formed in solution, then you'll see bubbles. If a gas is formed and you don't see bubbles, there are some other ways to test for different gases. Heat can be absorbed or released. So if it's significant enough, then the test tube or the beaker that you're doing the reaction in could get hot or cold. But sometimes those changes are so small that you would need a thermometer to detect them. You can have light being emitted, or you could have a precipitate formed. And a precipitate is a solid that's formed from clear solutions. So here's some visuals for this. We'll also do a lab or several labs in class, so you'll get to observe these directly. But that first picture shows a color change. So that's a color change as a result of the reaction. You can also see on that one, it looks like there's some steam coming off. So that one also has some heat being released. That middle one, you can see that's a stove burner. So that's a chemical reaction where you get heat and you have some light being produced. Or the one over to the right is an example of a precipitate. So that is a solid. You can see those two solutions start out as clear and then you get that white precipitate that's kind of falling to the bottom of the test tube. In the bottom, the first one you see are bubbles being formed. So you can see that tablet in the bottom that's reacting and giving off bubbles or giving off gas in solution. And then that final one is one you've seen before, I'm sure, where you have a light stick. So when you crack those light sticks, you're actually reacting two chemicals inside of the light stick, and then that light is being produced. So those would all be visual examples that chemical reactions are taking place. So a chemical reaction is represented with a chemical equation. So when we write out a chemical equation, you have the substances on the left, those are called reactants, those are present before the reaction takes place, and then you have substances on the right of the reaction, and those are called the products, those are what are present after the change has happened. That arrow that you see is read as a yield sign. So this would be read as reactants yield products. So again, the reactants are what you start with, those are on the left, the products are on the right. This reaction here is what happens when you light a Bunsen burner or you light a gas stove in your house. So CH4 is methane. So you would say methane reacts with oxygen to produce carbon dioxide and water, or you could say methane plus oxygen yields carbon dioxide and water. We can give a little more information in these chemical reactions or these chemical equations by adding abbreviations that let us know the state of the reactants and the products. So now you notice this is the same reaction, but we've added the states of matter for each one of these. So a gas is represented with a G, liquid with an L, solid with an S, and then an aqueous solution is represented with AQ. And an aqueous solution just means it's a substance dissolved in water. So the last thing we're going to look at today is how to balance chemical equations. So you've done a little bit of this already in the intro activity, but we're going to go through and do it in a little more systematic way. So we have to balance chemical equations to satisfy the law of conservation of mass. So that means that mass cannot be created or destroyed. So the mass of the reactants has to be equal to the mass of the products. So you can see the two examples of equations here. The top example, and again, this is our same reaction, methane plus oxygen gives us CO2 and H2O, or carbon dioxide and water. In the first reaction, this is how we wrote it on the previous slides. But if you notice, on the left side, you have 4 hydrogen, but on the right side, you only have 2. On the left side, you have 2 oxygen, but on the right side, you have 3. So that top equation is not balanced. So when we balance chemical equations, we can add coefficients in front of the compounds and elements in order to balance those equations. So then if you look at the bottom equation, that equation is balanced. So we have equal numbers of carbon on both sides, hydrogen on both sides, and oxygen on both sides. And notice the only thing that we've added here is we've added those numbers in front. So again, when you're balancing equations, you can only place numbers in front of the reactants and products. You can't change the subscripts. You can't put numbers in between the chemical compounds. The only place you can add numbers if you need them is in the front. If there's not a number there, then that's an implied 1. So you can write the 1 or you can just leave it blank, and that's an implied 1 in front of those compounds or elements. Okay, so we're going to go through a little more systematic way of doing this. So the way we did it in class yesterday was just, or the day before, was just kind of a guess and check method. If that was working for you, you can continue to do that. But there are some that are a little more complex, a little more difficult, that you may want to refer back to this more systematic method. And you can use this for every method if you want, because this is always going to work for you. So what we're going to do here is we're going to list the elements that are in the chemical equation under the yield sign. So I have an Na and Cl on the left and Na and Cl on the right. And you should have the same elements on both sides of the equation. So later on, when we get to where you're actually writing out these equations, if you end up with different elements on both sides, then you want to go back and check and make sure that the equation is written correctly. So then once you've done that, we're going to list and count how many of each we have on each side. So I have 1 sodium and 2 chlorine on the left, 1 sodium, 1 chlorine on the right. So now I'm going to look at this and see if there's a way where I can balance these out. I'm only going to focus on one element at a time, because usually what happens is when you fix one element, it will usually fix others. Now, sometimes it will make other elements become unbalanced, which is fine, because then you just go fix those and you keep fixing back and forth, guessing and checking until you get everything balanced out. So for this one's going to be an easy fix because I have 2 chlorines on the left, only 1 on the right, remembering that we can only place numbers in front of the elements and compounds. So I can't change the subscripts. I can't stick things in the middle of compounds. I can only put things on these lines that are provided. So to fix this chlorine, I'm going to have to put a 2 in front. Okay, knowing that that could throw something else off, but we can always go back and fix that. So then after I put that number there, I'm going to recount my elements that it affected. So now I'm going to cross these out and I'm going to recount. So I'm not adding to what's there, I'm recounting. So now I have 2 sodiums and 2 chlorines. And then on the other side, I still have 1 sodium and 2 chlorines. All right, so now I'm going to go back over to the other side because my chlorines are okay, but now my sodiums are off. So to fix the sodium, I'm going to put a 2 in front of the sodium. So now I'm going to recount that one. So now I have 2 sodiums, 2 chlorine, 2 chlorine. So this one is balanced. If you want to put a 1 in front of the Cl, you can, but you don't have to. You can leave that blank. So that would be that balanced equation. Okay, so here's another one. Same method, Fe, H, and Cl. I have 1 of each on the left, 1 Fe, 3 Cl, 2 H's on the right. Okay, so this one's going to be a little more challenging because it's not going to be as easy of a fix. So for this one, to fix my H's, maybe start with that one. I'm going to put a 2 in front of the HCl. Then I'm going to recount. So Fe is the same, but now I have 2 H's and 2 Cl's. Okay, so if I look at this now, I have 2 Cl's here and 3 Cl's over here. So there's no way I can get those two to be equal. So I'm going to have to put something in front of this that is going to be a multiple of those two. So if I put a 2 in front of this, now I have 2 Fe's and 6 Cl's. Okay, so that is going to have me to go back over here and fix the Cl. So I'm going to erase what I did before, and I'm going to try something different there. So now if I have 6 Cl's, I'm going to have to put 6 Cl's over here. Okay, so now that makes 6 H's and 6 Cl's. And then iron, I need to fix. So I'm going to make that a 2. So iron now has 2. So the irons are okay. The Cls are okay. But again, going back to the other side, to fix the H's, I have 2, but I need 6. So I'm going to put a 3 there. So now that makes 6. Okay, so if I go back and check, 2 Fe's here, 2 Fe's over here, 6 H's, 3 times 2 is 6 H's, 6 Cl's, 2 times 3 is 6, 6 Cl's. So this one would be 2, 6, 2, 3. Okay, so here's another one. So for this one, I have Si, O, and C. So 1 Si, 2 O's, 1 C. Other side, 1 Si, 2 O's, and 2 C's. So the C's are in 2 different places, but since they're on the same side of the equation, I still have to add those up. The ones that have elements in multiple places on the same side, those tend to be a little more challenging. When you're doing these, the best way to approach that is to leave those till the end if you can. You can't always, but leave those till the end if you can, and then balance those after you've balanced everything else. Okay, now on this one, since I have 2 C's on one side and only 1 on the other, that could be a place to start. So for this one, I'm going to put a 2 in front of the C. So that changes this to 2. And then if I look, everything else is balanced. So Si is still 1 on both sides. The O is 2 on both sides. Carbon is 2 on both sides. So this one, this was all I needed. Again, if you want to go back, you can put 1s there, but you don't have to. If you leave that blank, that's an implied 1. Okay, so this one starts out looking kind of complicated, but it ends up being very easy. Okay, last one. So this is one that has a lot of different elements here. So I have Na, H, C, and O. So I'm going to go through, start on the left. I have 1 Na. This one you have to be careful of because you've got elements in a lot of different places. So I have 3, 4, 5 H's. I have 2, 3 O's. And I have 3 C's and 5 O's. Okay, on the other side, I have 1 Na. H's, I have 3, 4, 5. Carbons, I have 2, 3. And O's, 1, 2, 3, 4, 5. Okay, so if you look at this one, 1 Na on both sides, 5 H's on both sides, 3 C's on both sides, 5 O's on both sides, this one is done. I don't have to do it. It's already balanced. So again, I can leave those blanks or I can put the 1s in. So just because something looks complicated doesn't mean it's going to take a lot to balance. Sometimes they're already balanced to start with. Now, when we get into a little more complicated ones, and you will have to do a few of these, there are certain types of reactions called combustion reactions that we'll talk about next time. Those tend to have really large coefficients. Most of these equations are going to have coefficients that are probably maybe less than 8, but there are some equations that we'll get into as we work through the practice where those numbers can get really large, and we'll talk a little more about those next time.